So we observe that this filter has zeros on the unit circle. The filter has zeros on the unit circle at z equal to e raised to j 2 pi k upon m plus 1, where this k will start from 1, 2, 3 and it will go up to m. So there are total m number of zeros. Now from where we got this, you can understand this from this expression of h of z that we had written. Now this is the expression that I had written some time back, and you can see that here there are m plus 1 number of zeros and there is one pole at z equal to 1. Out of this m plus 1 number of zeros, one zero will be at z equal to 1 and that will cancel out with pole at z equal to 1. So after that cancellation, I'll be left out with m number of zeros, and all those m number of zeros will be nothing but at mth root of 1. Now I hope you know how to find mth root. So square root, cube root and so on. If you find mth root of 1, we will get m different values. Otherwise, square root, cube root of 1 should always be 1, but I'm sure you must have done it in mathematics how to find multiple roots of 1. So this are the multiple roots of 1, m number of roots, e raised to j 2 pi k upon m plus 1, and k will take all these m values. So if I consider the relationship between z and k, that z is equal to e raised to j omega, the nulls, I can write that, occur at omega k equal to, so you can see I'm simply going to compare this omega with these values which are 2 pi k upon m plus 1, and this k will be 1, 2, 3 dot 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 up to m. Let us see one example now. In this example, I'm going to consider m. If I consider m equal to 4, in that case wk will be equal to 2 pi k upon 4 plus 1 will be 5, and k will take 4 values, 1, 2, 3 and 4. So one by one, if I consider all the 4 values, first value for k equal to 1, the first null will occur at omega 1 equal to 2 pi by 5. For k equal to 2, the second null will occur at omega 2 equal to 2 into 2 pi, that will be 4 pi by 5. For k equal to 3, the third null will occur at omega 3 equal to 6 pi by 5, because 3 into 2 will be 6 pi by 5, and k equal to 4, the last null will occur at omega 4 equal to 4 into 2, that will be 8 pi by 5. Now the range of omega that we generally consider is from minus pi to plus pi. So when I draw the frequency spectrum of this filter that we just now discussed, this time let us consider two-sided magnitude spectrum. I'm going to draw mod h of omega, and in two-sided magnitude spectrum my omega will vary from plus pi to minus pi to plus pi. So this is the range of omega from minus pi to plus pi. Now let's see how the magnitude response will look like. So we have to show total 4 nulls. 4 nulls, one will be at 2 pi by 5. So if this is from 0, this is the range 0 to pi, this will be pi by 2. 2 pi by 5 will be nothing but pi upon 2.5, and hence it will be less than pi by 2. So less than pi by 2 will be, let's say, somewhere here. So this is my first null at 2 pi by 5. The second null is 4 pi by 5, which will be twice of 2 pi by 5, which is very obvious, twice of 2 pi by 5, and hence it will be definitely greater than pi by 2. So let me take it somewhere here. So this is, let's say, 4 pi by 5. Okay, now let's see where is the third null. Third null is at 6 pi by 5. Now 6 pi by 5, if you observe, is greater than pi. So I have to consider a value of omega which is in the range minus pi to plus pi. 6 pi by 5 can be written as 2 pi minus 4 pi by 5. You can verify 2 pi minus 4 pi by 5 will be nothing but 5 2s are 10 pi minus 4 pi will be 6 pi upon 5. And this is equivalent to nothing but minus 4 pi by 5. So third null, that means omega 3, which is 6 pi by 5, is equivalent to minus 4 pi by 5, and minus 4 pi by 5 will be somewhere here. And the last frequency which we have got as 8 pi by 5 can be written as 2 pi minus 2 pi by 5, and 2 pi minus 2 pi by 5 will be equivalent to minus 2 by 5, minus 2 pi by 5 will be somewhere here. So I've got all the 4 frequencies at which null will occur. So now let us quickly draw the magnitude spectrum. Magnitude spectrum, it will start from positive, from some non-zero value. First null occurs at 2 pi by 5, second occurs at 4 pi by 5, and then the magnitude spectrum will stop at pi. On the other side, first null occurs at minus 2 pi by 5, then at minus 4 pi by 5, and then frequency response will stop at minus pi. So this is the frequency spectrum of the filter that we just now discussed. You can see this is called comb filter, especially because there are multiple notches or perfect nulls, and all these notches are occurring periodically. You can see the frequencies are minus 4 pi by 5, plus 4 pi by 5, minus 2 pi by 5, and plus 2 pi by 5, and they are nothing but harmonics of each other. We conclude that moving average filter is nothing but a comb filter, and similar to notch filter, we can design comb filter by introducing periodic zeros on the unit circle at corresponding frequencies at which we require notches to occur.